All right. Yeah, I have turned it on. So we have been working with SIP on the server side for quite a couple of years. SIPwise exists since 2008, and we have used SEER and OpenSEER before. But we recently had a fair share of experience also from an application point of view, like from an endpoint point of view. I think most of you guys are actually also on the server side, so you're operating SIP proxies, SIP systems. And since WebRTC is actually catching up quite fast, people start doing real-time communication applications in a quite a different way nowadays. They come up with different use cases. We are going to look today into how this signaling in media communication works or does not work from an application developer's point of view, who usually doesn't have a whole lot of experience when he comes from the web to do like SIP and XMPP stuff and even RTP, for example. So, as we know, SIP is pretty much the standard in telco environments, so nothing new here. And SIP is also used or designed kind of like as an end-to-end protocol. So there's lots of routing information in order to traverse more or less complex networks. It has lots of extensions to do things. We've heard from Ole already how those things evolve and what we're still missing. What this end-to-end thing also means for an application developer is that the responsibility of doing all the things right in order to do some SIP application, it's quite a burden and it's quite a lot, right? But anyways, if you're looking into how these SIP networks are typically deployed, then it's really not exactly end-to-end in terms of how it was designed, because typically you just have like, one or two or maybe 3 hops in your network which you really can do based on your SIP routing. And then some kind of P2P UAs or SBCs hit in because operators are typically quite afraid of leaking internal network information to the public, right? So in theory, you could really do an end-to-end call and you see how the calls traverse through your network. And there you basically expose network information of your own infrastructure, and an operator usually doesn't want to do that. So what we get there anyways is kind of like P2P UAs, SBCs, which are breaking the end-to-end concept. And if we're speaking about IM and presence, like taking the normal, let's say, SIP core flows to create a voice or video call aside, but go into more complex scenarios like presence or buddy list, then there's SIP Simper, but it's really a pain, and it just, for interoperability issues, it really just doesn't work in reality, right? But what's there is that XMPP, for example, just works. And it's also rather simple, it's extensible, but it can become pretty complex very fast if you think about implementing like more advanced scenarios with XMPP. So for example, if you look into Jitsi Meet, for example, and you look at XMPP messages being transported through the network, then it's quite a nightmare actually, like lots of XML and you have no clue what's going on there. So it's pretty impressive, but it's not like something you want to really work with as an application developer. And the other thing is, if you do XMPP and want to use some kind of like unified communication scenario or have a unified communication client, then typically you end up with a dual stack implementation. So you use SIP for your voice and video calls, and you use XMPP to share your buddy lists and to presence-related stuff, messaging, multi-user chat, and so on. And then again, if you somehow want to transport that in a transparent way, for example, if you want to send an XMPP message to somebody and you figure out in the backend system that that's actually not the XMPP user, neither on your network nor something you can federate with, then you need to bridge those kind of things anyways. For example, if you have like a desktop SIP phone who can only do SIP, then you probably want to bridge the XMPP chat messages to SIP messages back and forth. And there's quite some complexity going on there. So it's not like something which just helps you very much in terms of simplicity. And if you're speaking about mobile applications, you get additional things into play, like device constraints you typically don't have on a desktop soft phone, like power and connectivity changes. And one of the problems with SIP really is, it drains the battery. I mean, you need to be online all the time, right, in order to receive calls. So you need to keep your connection alive. And if you're using XMPP side by side as well for a unified communication stack, for example, it drains the battery even more so because XMPP is rather chatty in terms of, you get lots of presence updates and so on. And the problem there is if you put your application to background, and probably the Soipa guys can tell something about that, it gets really unpredictable in terms of when your operating system like Android or iOS is going to kill your application. And you're just offline, you can't receive any calls anymore. You probably are not even realizing that. So when we were implementing our soft phone product to work with our server side, we settled actually for push notifications. Like the idea was you want to be online in terms of connected via XMPP and registered via SIP just for the time you're actually interacting with the application. And then if you put it into the background, it just stops, right? So it saves the battery, you don't have any traffic on your network, and so on. The problem there is really that you add another thing to SIP and XMPP, right? So you need to send a push notification token to your server. You need to register it there. You need to have that on the server in order to do or to deliver a push notification to Google or Apple services. And the question there is then, okay, how are you going to transport this token to your server side? So you could do it via some custom SIP extension, like a P header or something like that. You can transport it somehow via XMPP. Or you could just use a simple HTTP API, right? The problem is, if you're looking from a perspective of an application developer to those kind of problems, you rather probably have a hard time to extend your SIP stack. You're basically using something like PJSIP and SMAC or whatever, and modifying that on a client side is pretty hard, or something you really don't want to do, and you need to modify your server side to extract that kind of information. So it gets pretty hard because app developers, typically like general purpose app developers, they do great apps. I mean, some of them are great, but they are basically specialized into showing pretty user interfaces, fetching their data via some HTTP call, and then render it somehow, right? But if you go into implementing like a SIP and XMPP phone or client as an app, it doesn't matter whether it's a native Android or iOS app or whether we are speaking about a JavaScript WebRTC application, you suddenly need to deal with state machines and all these kind of things. So it gets quite a nightmare. So for us, it took like 3 turns in order to get it right with like 3 different teams to really get up with a third-party applications like app developing company to make that really work. And as I said, I mean, the main question is who is actually going to develop the apps? I mean, we are, as I said, we at SIPwise specifically, we are just server guys typically. So we get like general purpose app developers because there are not so many SIP client developers out there, and try to do or make them do things, right? The same is true for web ideas or web applications. So it's probably not us doing, like us, the telco guys doing the applications, and we know how to deal with SIP and XMPP, but those guys, they don't, right? They just want to do their typical HTTP communication and nothing more and nothing less. And also, I mean, we are quite, I mean, probably from our mindset, we are also a bit narrow, maybe, that we are not going to come up with the new brilliant ideas of real-time communication applications, right? Because we come up with dial pad phone widgets in WebRTC, or a call me button, or maybe a video conferencing solution, but I mean, that's not clearly the interesting things. I mean, it has their places in the market, but there are already so many, and I mean, that's not the new brilliant ideas which are going to take your startup or company off the ground. And the thing is, how big is really the barrier for getting new or fresh ideas into this kind of ecosystem, like having app and web developers to come up with ideas and being able to implement a new kind of application. And the thing is, those app developers, they're expecting something different than SIP and XMPP. And we probably don't want to hear that, but I mean, they are used to using HTTP and WebSockets and transporting some JSON between them. And you have quite dedicated services and apps for specific use cases. So you really typically come up with your own communication protocol just because you need to make that kind of scenario work, and you want to make that work in the simplest way possible. And the technical challenges there for this kind of real-time communication things, they're rather simple. So you really do not want to have something like a SIP and XMPP overhead just around that, just in order to make like a one-way video connection to someone else from your browser. And certainly they don't want to implement a SIP and XMPP client implementation in JavaScript or use something like that. They don't want to implement like an XMPP client and a SIP client in their web application just to do or just to negotiate a video connection. And that's something we have to admit and we have to live with, also specifically from a, let's say, Kamailio or SIP ecosystem part. So, again, there is quite a gap between the mindsets of we as telco developers and the web developers or app developers, because we are still dealing with the interesting stuff, advice of charge and DTMF and fax and things like that. Well, actually, if you want to implement an interesting and appealing application, you really want to just know how to share a file or share an audio or video snippet or share a location via your web application. And I mean, if you ask like the SIP guys, then they are probably coming up with answers like, okay, you can use MSRP for your data transfer, or you can use BitFlow for your sharing location information. And this is just a nightmare, right? I mean, you're just using SIP because you know SIP, or maybe you map that somehow into XMPP, but that's really, again, not what those app developers are used to or what they are going to expect from you. And also due to this complexity of the protocols we are dealing with here, then from our experience having something like a voice over IP or unified client, implementing a unified communication client, it takes you something like 6 man-years or something to make that work. Maybe longer, I mean, maybe shorter, but it's at least not something you can come up with in a couple of weeks, for example. And our experience has been that the app developers who are implementing those kinds of things, they need to deal with like SIP protocol specifics or XMPP protocol specifics instead of actually implementing the kind of features they want to deliver, right? So they waste their time on making like just the communication work due to the complexity of the protocols we're dealing with. And the complexity gets really high if you want to do SIP or XMPP. As I said, I mean, okay, adding a custom header just to transport, a push token is one thing. But if you want to use SIP to transport location information, you deal with large XML files. You need to parse them, maybe in Kamailio or whatever. And it's just not necessary, right? And if you say, okay, XMPP is extensible, I can just write my own extension, an application developer is really not supposed to do these kind of things, right? I mean, he's not supposed to extend the XMPP protocol, even maybe going through or publishing some XEP for that or something. So what they actually want to do is they just want to use HTTP for that, right? I mean, they just do an HTTP API call and fetch the data they want. And if they want to have two-way communication, they just build up a WebSocket and transport some JSON information between the client and the server, and that's what they expect. In terms of ideas or use cases for real-time communication, what we have particularly worked with in terms of WebRTC recently is, for example, to have a remote support application, like a web application, where you, for example, as a customer of an operator, you call up the hotline and say, hey, my internet doesn't work, right? And then you have these scenarios like, okay, which LEDs are blinking on your modem? Which cables did you connect? So what we tried to come up here was a very simple application where the agent in the call center could just say, okay, I'm going to send you a link somehow, could be SMS or could be via email or whatever. And while the user is on the call, he just receives the SMS, clicks on the link, and the application builds up a one-way video connection back to the agent, where the agent can then see what the user can see with his camera, and the agent can tell you, okay, you show me your router, right? Or show me your modem, and show me which LEDs are blinking, show me how you did this or that. And that's not your typical SIP scenario. I mean, you probably do not want to use SIP for these kind of things, right? Because there's no call involved. There's no need to do any interconnection with the typical voice network or SIP network. So the idea there was really, as I said, we are not application developers. So we use companies, third parties who are going to develop these kind of applications for us. And when you're talking with them regarding their requirements, is basically you need to make it as simple as possible. So you cannot force these guys to use JSIP.NET just for implementing a SIP stack in their application to do some SDP signaling, because that's pretty stupid, actually. So what you need to provide, what we needed to provide, is a simple JSON protocol, which they are used to. They can send that via WebSocket, and ideally you wrap that protocol into an SDK. So the only thing this application developer does is in his website to just load the JavaScript file, instantiate an object, and say, okay, I need to call this number or whatever. And then the rest basically needs to work internally, like hiding your WebRTC API calls, hiding your ICE handling. Those application developers, they don't care about those things, and they don't know about those things. They don't know what ICE is. They don't know what RTP is or whatever. The only thing they want to know is, I want to call them, and when the call is successful, I want to get a callback with a video element, which I can embed in my HTML, right? And this is what they expect, and this is how they can quickly iterate on the feature, on the product, and not deal, with the details of the protocols. And yeah, and therefore you decrease significantly your time to market with your application you're going to have developed or developed by yourself compared to a SIP XMPP stack. So our approach to that challenge basically was that we introduced a middleware called RTCEngine. It's pretty much a WebRTC gateway, if you want. And it has been a joint development between Deutsche Telekom and specifically their T-Labs R&D department and Zipwise in order to provide a very simple way for application developers to create real-time applications while at the same time still being possible to do your SIP and XMPP interconnects if you want. So what it does is really it's a middleware running on the server side. And it exposes a JavaScript API to the developer, like an SDK. Basically, you just load in JavaScript. And if you really need to, it converts your JSON data you send between the client and the server via WebSocket. It converts it to SIP, XMPP, and can be pretty much anything. It's like a modular approach you can extend. On the server side, dealing with the specifics of SIP and all these kind of things. So what it also does with the help of Kamailio and RTCEngine, and this is something we have been done for years, and it evolves more and more, is it also transparently bridges your WebRTC media to plain RTP, because we have heard today already quite a lot about SDP being very complex, and you have these DTLS connections which typically SIP devices don't support, like gateways or old-style ATAs or whatever that might be. So what we can do is pretty much kind of like what Lorenzo was mentioning with Janus, is leveraging Kamailio and RTCEngine to convert the media between a WebRTC endpoint and a plain SIP endpoint if you need so. If you don't need that, because you have just two WebRTC endpoints, you can just forward that end to end. You don't have to deal with the media. And what you can also do, and that's the good thing, is you can just leverage like third-party application servers in the middleware. So if you're going to create like a conferencing application, you create a module in the backend, which is going to communicate like with, again, via an HTTP protocol maybe, or maybe even via SIP if you need, with third-party servers like Currento or Dialogic XMS or possibly Janus. We've talked about that yesterday. It looks pretty appealing, so I didn't know it before. So that might be something we're going to do. But then again, you're like, okay, you're coming up with your own JSON protocol, and it's like something proprietary if you want, but still you don't need to have any compromises in terms of troubleshooting, because what we did, thanks to the guys from Homer, is making the signaling transparent in Homer as well. So what you do is, for example, if you have a simple application from your on your web page, and you start to initiate a call, for example, via the JSON protocol, and you need to convert that to SIP, for example, to call, I don't know, my mom, then what Homer can do is it correlates my JSON messages and my SIP messages the same way it does with plain SIP. So basically you get an overview of, okay, I got a call start from the, via JSON from the web client, which actually is going to be converted to an invite on the SIP side. And then I see my SIP signalization, and once the other guy is sending back 180 or 183, we send back via JSON a ringing event, and if he picks up, we send an accepted event, and if you end the call, then it's going to convert again your JSON protocol to SIP, and you see that transparently in your core flow diagrams in Homer, for example. And the other good thing there is that if you route your traffic via Kamailio, and we invoke RTCEngine with that, Lorenzo has mentioned that yesterday already, RTCEngine has support for providing RTCP stats to Homer. So suddenly you can get RTCP information, like providing your MOS score, for example, for a call you do via WebRTC, and you still have the same visibility and the same tools basically to troubleshoot your applications. And what you can also do then is you can just, if you have a WebRTC connection, you can, in the future, like read peer connection information from the client and send it via JSON to the RTC backend, and then feed that, for example, into Homer as well to get a real end-to-end view on how the call quality was. We have our desk out there together with the Homer guys in the exhibition hall. So we can show you those core flow diagrams in detail there if you want to have a look how this is going to work. And since it's a foundation for modern web applications, we also have the demo, like I mentioned before, with this call center scenario, to show you how this is actually going or is implemented on top of RTCEngine. And yeah, and Homer is actually visualizing you the signaling and the media which is going on in the background, which is really neat because people are used to those troubleshooting tools. You can just reuse them further. All right, I'm done. I was the last one, I think. I hope it wasn't too.
Last before the last, but the most important.
Hi, at the beginning you were talking about the battery consumption of continuously sending SIP register messages. But I was just wondering, how did you find battery consumption different with a WebSocket where you need to continuously send keep alive messages to keep the TCP connection running?
You're still using push for that. So basically, you just end your application. If you get a call or a message or whatever event you need to consume as a client, then you get a push notification to say, OK, you have received a message from this or that guy. You click on that, and then the app starts, connects, and gets the message in the protocol. The good thing about that is that the whole communication, like what you expose via XMPP, for example, you can filter that quite efficiently on the server side, because you know if the client is connected or not, and if there are like presence changes or things like that, you just don't forward those kind of things, or you don't trigger like a push notification every time one of your buddies goes from online to PC or something. So it's basically the same concept. It just narrows the whole thing down, right? First we had like SIP and XMPP and then HTTP API to share like location, stuff like that. And nowadays, basically, what we are going to we still haven't changed our native application. It's just in progress. It's working for the web part. But it's going to use just one HTTP connection then for all these kind of things, and which makes the life of the application developer very, very simple.
Yes, thanks for the talk. Just a question about RTCEngine, and why do you think it was necessary to implement the full ICE? Why didn't you continue with ICE Lite, being server-side hosted component, and brought all this complexity and incompatibility, and yeah, we had to fork that day.
Okay.
If ICE Lite would be back one day, it would be a celebration.
It's not going to go away, right? We just implement whatever is necessary to implement, so we're quite pragmatic on that approach, and a lot of people were requesting that for different use cases because specific use cases didn't work. I can't tell you the details of which use cases that was. Could you get you in touch with the guy doing these kind of things? But it's not going to go away. Well, that could be an option, yeah. So we could discuss about that, sure.
More questions there about, otherwise, again, they have here the demo, so you can see it's live, it's real time. And just to end up with a question, because yeah, everyone is enthusiastic about like bringing all these web developers to the real-time world. Do you think it will happen at some point, or these guys are still going around us with other tools?
At the moment, it pretty much works like that. It's still like we are coming up with the ideas, but we are not, or we in our team do not have the right people to write like fancy web applications, right? We are like coding kernel stuff for RTCEngine and doing some C code for Kamailio and stuff like that. But we are not web designers, app designers, UX experts. You have the right guys out there, right? But they don't know anything about what we are doing, and somehow you need to bridge them together. And currently it works like that, okay, you can come up with an idea and say, okay, we need to have this implemented because the customer needs it, and then you just leverage or like outsource this kind of development work. And that works pretty well, right? It didn't work before when we used like SIP and XMPP and all these protocols. Nowadays it just works. And you still can use SIP and XMPP in your background if you want to need so. But the middleware decides what it's going to do with that and not the application developer.
Okay, so thank you, Andreas. Again, you find them outside.